Yeah. Hello, my name is Dr. Gleisner, and I'm talking about amounts of substances in equations, which is mainly for higher tier, but it's not that difficult. Okay, so the first thing that you've got to do when you are faced with calculating masses in an equation from an equation is that you need to look up what the masses are of the things that you've got in there. So magnesium has a mass of 24 neutrons and protons, which we know is per mole is 24 grams. If you are not familiar with that, watch the video just prior to this, which talks about what moles are. Okay, so hydrogen chloride is 1 plus 35.5, and these numbers will either be given to you or you will have a periodic table in which to look them up. So the molar mass of that is 36.5, and then of course you've got the combination of chlorine, which is 2 times 35.5, which is 71 grams plus 24 grams. I'm sort of abbreviating that slightly. Okay, so that is, why am I doing this in my head? 95 grams. If that is wrong, I'm going to have to record this video again, so hopefully it's not wrong. And that is 2 grams because it's got 2 protons, and that's all there is to it. So on the left-hand side, you've got 24 plus 2 times 36.5 because you've got the hydrogen chloride there twice. And then on the right-hand side, you've got 95 plus 2, which is 97 grams. So let's just make sure that that's okay. So that's 73 plus 24, which is also works out as 97 grams. Lovely. Okay, so we know that our mass is okay there. So you don't have to do all of this in order to prepare for this question, but it is a very nice way of just showing that if you had 24 grams, so if you had 24 grams of magnesium and you had an excess of hydrochloric acid or hydrogen chloride, then what you would get is 95 grams of magnesium chloride and 2 grams of the hydrogen. So that is the simplest case of a question that asks you for amounts of substances in equations. So let's see how much I can get rid of from the undo function. Oopsie daisy. There we go. Okay, so let's say you've got awful numbers, and I will just give you a not so awful number, and then we'll really ham it up and give you a really awful number. So let's say we know that the molar mass of that is 24, and the molar mass of that is 95, and that is 2. So let's say you've got 2.4 grams of magnesium and you've got an excess of hydrogen chloride. Then the question is maybe how much magnesium chloride and how much hydrogen do you produce from that? And you can see that 2.4 grams would just be a tenth of the molar mass. So all you have to do is really put a tenth of the masses on the right down, and you would be right. And the reason for that is because it's proportional. Everything is seen in terms of the ratios of this 24 grams to those 95 grams. Let's pretend for a moment that we're only interested in the magnesium chloride. It doesn't really matter. You can say, okay, it goes from 24 grams to 2 grams in terms of the ratio. That's also okay. But let's say we're interested in making magnesium chloride from magnesium. So let's say we have got an awful number, and that awful number is, let's channel my question setting brain, and let's say that's 1.935 grams. So you start off with 9.35 grams. So how much magnesium chloride would you make? So if you use ratios, then the answer is straightforward, because if you had 24 grams, you would be making 95 grams. So if you had 24 grams of magnesium, you would be making 95 grams of magnesium chloride. But you don't have 24 grams, you have 1.935. So all you've got to do is figure out how to get from 24 grams to 1.935, and then do the same thing on the other side. So this is a foolproof way of doing it. You divide it by the number that you've got to get you to 1, and then you times it by the number that you want. Now you might think, what on earth is the value of that on the left-hand side? And the value is nothing, but you get from 24 grams to 1.3935. So that shows you what you need to do with the number on the right-hand side in order to get from 95 grams to the corresponding number of 1.935. Okay, so you divide by 24, and then you times it by 1.935. So again, dividing it by 24 on the left-hand side gets you to 1, and then you can just multiply it with the number that you've got. And on the right-hand side, you divide the 95 by 24, and you times it by 1.935, because that will give you in proportion the number of magnesium in grams of magnesium chloride that you've got. So let's just use a calculator for this, because my mental maths is bad enough without having to torture myself over that. And then we'll do a sanity check and see whether that is correct. So 7.659 is the answer for that. So that's rounded to the 4th decimal. So let's have a look and see whether that makes sense. So 1.935 is close enough to 2 to say that I've got about a 1/12 of 1 mole of the magnesium. So 7.89659 is close enough to 8. So if I multiply 8 by 12, I get 96. And again, that shows me that it's around about a 1/12. So this is at least in the right ballpark. Okay, so it's probably the correct number, and I've barring any typos, of course, in the calculator, and that is okay. So how about if you've got a question that asks you to do that same thing, but this time you've got tons, okay? And let's say you've got 1,000, I don't know what, no, 3,000, because we've done 1,000, quite a lot. So 3,126 tons of magnesium. So how many tons of magnesium chloride would you get? Well, the first idea is you would get a lot more, because from 24 to 95, that's roughly a factor of 4 going up. And that's another way that you can check this. So 1.935 is roughly 2, and then times 4 is roughly 8. So that's about right. So we'd expect about 12, the answer to be about 12,000, something or other. Okay, so 3,126, you do the same thing again. It doesn't matter that it says grams here, because what you're interested in is the ratio of the grams, and ratios don't have units. How do I get from 24, I shouldn't have two things at the same time. Okay, how do I get from 24 to 3,126? And the same thing applies. So you divide it by 24 initially, and then you times it by 3,126. And then you do the same thing on the right-hand side. So obviously I'm not going to do that on the left-hand side, because on the left-hand side I know it's going to get me to 3,126. And on the right-hand side it's 95 divided by 24 times 3,126, because that's what we want to get at. And that's 12,373.75. And this time the unit is tons. Okay, so what did I say about 12,000 tons? That seems legit. Okay, there we are. And this applies to any numbers. This applies to 0.035 grams. This applies to any number that you might want to do or have to do. Okay, so again, any more questions, let me know, and I'll do another video with example questions. But doing it by ratios, I feel, is the most straightforward way of doing it. Thank you very much, and see you in the next one. Please like and subscribe, and let me know of any questions you'd like me to cover in the comments.